We are given in the question that the line, this line, does not meet. Does not meet means does not intersect the curve 4x squared plus 3y squared minus k. And this k being an unknown constant, you are supposed to find the range of values of k. So having the n in mind, you know that range means k is not equal to a specific value, it is a range of values. So this will be the n in mind. You need to, a good practice is, once you have read the question, write here some inequality, okay, to remind yourself in pencil that it must be an inequality answer. Now the very first thing you need to do, because you see that this equation consists of x and y, this equation consists of x, y and k, you can have k in your equation, but you cannot have both x and y. Okay, so what you need to do is to somehow eliminate one of the unknown, and I've chosen to eliminate this y. Okay, so I call this, I don't want to copy again. You notice I didn't copy again, I don't waste time. I simply write this in my exam script, call this 1, call this 2, then I say sub 1 into 2. That will save me the time of copying this, save time, and I save the I prevent myself from so-called transfer error, okay, just in case I copy wrongly. Now why does this subbing in of this equation into this other equation work? Somehow nobody asked in class, I presume you all know, but I don't think everybody knows. So this is how it works. Let's say you have this equation. Okay, I give you an easier equation than this so that you can understand better why we need to sub one equation into the other and how come it works. So let's say you have a curve such as this, y equal to x squared, you know it's a happy face, and if I go and plus 2 here, you would know from your E next that this is just a happy face cutting the y-intercept at 2. Okay, so this is your curve. Let's call this equation 1. Now if I have a line, and in this case for the sake of simplicity, I will have this line y equals to 0, okay, which is the x-axis. Now when I have the first equation being subbed, that means when I sub this into this, don't you agree that the y disappears, leaving me with x squared plus 2 equals to 0. Now this x squared plus 2 equals to 0 is a totally different looking equation from this original one, okay, but they are actually equivalent. This combined with this is actually equivalent to this. Okay, that means we are assuming that this curve here, which is on the left side, cuts this line here, which is this line here, okay, which graphically you can see that they do not cut. So if I want to do it algebraically, I will be able to see that, oh yeah, when I try to solve this, right, I will be square rooting a negative number, so there's no solution, which is rightly so. Okay, that's why this method of subbing one equation, the curve or the line, into the other equation works. Okay, now the other thing that you need to understand why b squared minus 4ac works also, okay, I will explain it later. I'll just explain the algebra here first. Now you sub this in here, then you expand, right? You will get this. Now bear in mind, a very common mistake is to think that this is 16 plus 4x squared. It's not true. So this is, if you were to expand it correctly, it is this. Okay, now what I need to do from here is I need to change it into a quadratic equation of the form ax squared plus bx. So my b is minus 46, my a is 16, and my c is this whole thing without, this whole thing does not contain any x or x squared. Okay, so essentially I am arranging this in the form of ax squared plus bx plus c. Why am I doing that? Because ax squared plus bx plus c equals to 0. Why am I doing that? Because when I arrange a quadratic equation into this form, I will be able to use the quadratic formula. Okay, but I don't want the hassle of having to use that whole big formula to find whether my answer is correct or valid. So I zoom in on the most important part here, which we call the discriminant, to help us to, it's a litmus paper to help us to see, just by using the constants a, b and c. This c includes the minus k here. Okay, so you can see that if they don't cut, that means there's no solution, just like the example that I gave earlier. There's no solution. Okay, then definitely the only way for there to be no solution is that the argument inside this square root, this whole thing, is less than 0. That's why the condition for not meeting is b squared minus 4ac less than 0. Okay, and if I were to continue working, ding 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 ding, then I will get all this. Alright, now this is a simple quadratic equation, sorry, it's not even a quadratic. This is a simple linear inequality. Okay, so it's very easy to solve. Alright, but as mentioned today in class, you need to be able to solve quadratic inequalities. And let me just say again how to do quadratic inequalities. Okay, if you don't know how to do this question, that's it, that's the end. You have found the range of values already. Okay, but more importantly, I want you to be able to solve quadratic inequalities, because that is very important for your syllabus. So if you happen to work out, this is an example, nothing to do with this question. Okay, you get something like this, minus 6, less minus 6. Okay, then less than 0, example. Okay, then you will have to factorize. And then from here, okay, I want to repeat again, the answer is not x plus 1 less than 0 or x minus 6 less than 0. If you do this, continue to do this, some of you are still doing this, immediately is 0 already. Okay, so this is wrong. So what you need to do is to draw, always make this a happy face, so that it's always a U shape. And then x, one of the values is minus 1, the other value is 6. Okay, and this part here tells us that we want the curve, the part of the curve that is negative, so it's this part here. So we want all these x values here between minus 1 to 6. So x, oh sorry, not x, okay sorry, I wrote wrongly, it should be k. Okay, but you should be able to solve this even in x, whether x or a or b or c or whatever the letter is here, you should be able to solve. Okay, so this sign, if there's no equal, don't need to put equal. If there's an equal, then you just put equal. That's it. So it's in between this. Now when will it be the other case? Okay, when will it be the other case? I show you what I mean by the other case. Okay, so again, it's a happy face, right? Happy face. Then down here, instead of wanting the negative portion of the curve, you want the positive portion, which means you want your x or your k, whatever is the unknown here, you want it to be less than minus 1. You want it to be here, this way, or you want it to be this way, k greater than 6. Okay, so you got to know how to solve this, because you may not end up with a linear inequality, you may end up with a quadratic inequality. Okay, so that is all.